So some of the features of PPP, some of the different items you can configure: authentication, being able to configure credentials for both sides, being able to authenticate the other side, one or two-way challenging and response; multi-link, being able to group multiple interfaces together into a single logical link and being able to interleave items there; reliability, getting into using the ability to number the frames and being able to verify information made it through safely to the other side; error quality, being able to look at the quality of the line, able to determine whether or not there's other problems with the line, with other drops, and being able to take down the line if the quality falls below a certain level. We also have other miscellaneous options: optimized negotiation, being able to kind of guess at what's going to happen, and some routing functionality. So routing functionality, we have the peer neighbor route, which we'll talk a little bit more about later. The peer neighbor route itself being able to have local routing installed for the remote end of the link. PPP authentication, being able to set up some sort of credentials for the connection and authenticating the other side. Now, some of the different mechanisms that we have available, two most commons being PAP and CHAP. PAP using a clear text username password, CHAP getting into hashed information, not sending that password in clear text over the line. Now, there are also other items, other possibilities as far as the command option for the PPP authentication: MSCHAP, MSCHAP v2, EAP, the extensible authentication protocol. However, PAP and CHAP are two that are most common. So with PAP authentication, the username and password information is sent in clear text over the line. Now, if it was a dedicated line, generally not a problem, but if it was something that someone else could be listening in on, someone else could be able to gather your username and password credentials. Now, with the PAP authentication itself, we have separate parts to it. We have the authentication request and the authentication response. Now, the default is to always respond. However, the request itself needs to be configured. So the first configuration line we have here, PPP authentication PAP, is going to configure one side to go ahead and request authentication and challenge the other side. In addition to that, having the PPP PAP sent username and the user information and password and the password information. Now, CHAP being another authentication method for PPP, again having the same sort of functionality, having the authentication request and the authentication response, the default being to respond to the request. The request being configured on one side, PPP authentication CHAP, and that side would challenge. If you have PPP authentication CHAP on both sides, then both sides would challenge. Now, other things slightly different with CHAP. By default with CHAP, it will send the host name of the device unless you have a interface host name configured or interface name configured for CHAP. And passwords as well. Having interface password will override the global configuration as far as the credentials being used for what's sent. Now, it doesn't actually send the password on the line. It does have the MD5 hash being used for that. In verification, debug PPP negotiation and debug PPP authentication, again, just like with PAP, same two debug commands, being able to verify that the line is coming up and is properly being authenticated. Alright, so we're going to take a look at some authentication. So we're going to start off with a basic connection between router 4 and router 5. Take a look at our basic starting point that we have here. Now, initially, the config we have on these two devices is a back-to-back connection, so starting off default of the HDLC for the encapsulation. And take a look at the config on router 5. And just verify that we do have existing connectivity with the current HDLC connection. So from router 5, able to ping across to router 4. We're going to go ahead and adjust this configuration and adjust this for a PPP configuration. And we're going to start off by just changing our encapsulation to PPP, and this will take our line down. And we're going to do the same on the other side. And our line should come back up since they match on both sides now. And our interface here showing as encapsulation PPP. So we're going to go ahead and add on some authentication. We're going to start looking at PAP authentication. PAP, as mentioned earlier, was clear text, so having a clear text authentication mechanism. Now, the default being that either side will respond. Whether or not you have the command configured will determine whether or not that side is going to initiate the challenge. So we're going to go ahead and just turn it on one side. So on router 4, we're going to have router 4 send out that challenge to router 5, so PPP authentication PAP. And we're going to switch over to router 5. Now, since router 4 is challenging, router 5 needs to respond. So on router 5, we're going to go ahead and configure a PAP username and password. Under the interface, PPP PAP, sent username, and we're just going to use username as Cisco and a password as Cisco. And switching back to router 4. Now at this point our interface is showing as down for the line protocol. We're also going to exit off of the configuration and enter username information. So here we have the credentials matching what's configured on the other side. And there we see our line protocol coming back up. We're going to take a look at some debugs and see what's going on here. So on router 4, having router 4 challenge router 5, router 5 responding back with the credentials configured there, and router 4 having corresponding credentials configured globally to be able to authenticate that user. So we're going to go ahead and we're going to turn on some debugs. Debug PPP authentication. Verify our logging level for the console. So our console is set to the debugging level. Had some of the debugging going on earlier, so you have some earlier messages logged. Now we're going to go ahead and just on the interface, shut down that interface, and then watch what happens when it comes back up. And shutting it down and waiting it for it to go full down and showing the line protocol change. And go ahead and trigger a no shut here. So see we have the login request and login response, authorization request, and the authorization response. So showing that we passed the authentication. So in this case, as showing here as PAP, PAP being the information there, and again showing the information coming from Cisco as the username configured there, authenticating that peer, and showing that we do have the authorization of pass. Next, we're going to take a look at CHAP. And we're going to go ahead and just shut down the interface here. changing the interface settings to use CHAP for the authentication. And we're going to go ahead and just do a no shut and watch what happens here. Now with CHAP here we show that we have information being passed on but not getting the response back that we need. So in this case showing that we have the outbound challenge but not receiving the information back. So we're going to go ahead and configure our credentials on the other side. And just configure the host name of Cisco and password of Cisco. And here we can see our interface has come up. And again, taking a look through what we see here, we have the outbound challenge coming from ourselves, rack 20R4. Inbound response coming from the other side as Cisco. And login information being sent back and forth. Authorization shown, responsive pass, and received information, sending out success, and the line protocol changing to up. So there we have just a basic PAP and CHAP configuration. We're going to go ahead and adjust the other side here. Turn on some authentication here as well. And switching back to router 4. Now, turning on the authentication on the other side, as in requesting the authentication. Again, the initial command PP authentication CHAP. The one side challenging. So in this case, taking a look at our debug here, I'm going to just shut down the interface and stop that. The information we see two challenges, and one of those being an outbound challenge, one of those being an inbound challenge. So again, having the differences there, whether you're doing it one-way challenging or both directions challenging. So in this Cisco implementation, having the PP authentication CHAP being the side that's challenging with CHAP, and then getting a response from the other device. So in this case, we have an outbound challenge, with our outbound challenge coming from the local host name by default, inbound challenge coming from Cisco. So the default here being what's the local host name of the device, unless you have other credentials specified. So in this case, at the remote side, we had the other credential specified, that username of Cisco. Locally, since we do not have anything else specified, defaulting to the rack 20R4. So we're going to go ahead and adjust that. We're going to go ahead and change the outbound credentials that we have here. And on our interface itself, PPP CHAP, host name, and we'll just call this R4 Cisco. And PPP CHAP, password Cisco. And switching back to router 5. And I'm just going to go ahead and add the credentials locally there. So we have username and password configured locally that matches what the other side is sending for credentials. I'm going to switch back to router 4 and we go ahead and bring up that connection again. So again, here we have an outbound challenge, inbound challenge, outbound response, inbound response, and then success. Outbound success and inbound success. And our line protocol does change to up. So things to be aware of, again, the authentication can be unidirectional, can be bidirectional. The PP authentication command on one side specifying to initiate the challenge and challenging the other side. Credentials being specified. If you have a username specified for CHAP, using that, otherwise defaulting to using the host name of the device. Make sure that you have the matching credentials on the opposite side. In this case, also turn on your debugs in order to verify where the problems are coming up. So in this case, seeing the challenges out and the responses back, you could possibly see a response back from a different name than you have configured. So in this case, having a challenge, inbound challenge from Cisco, if I didn't have those local credentials to verify, not able to double check that my local information, CHAP not sending password information back and forth, just hashing information and having that hash being sent across the line. So in this case, you need to make sure that you have those credentials on both sides. And again, the items configured not having to match. In this case, two separate usernames, but just having that password in common. PPP multi-link, allowing you to bundle multiple links together. So not required, it's an optional feature you can add on if you have multiple links going between the same devices. Being able to optimize the utilization of those individual links by fragmentation of the packets themselves. Configuration fairly straightforward. PPP multi-link, having a multi-link interface configured. Verification, show PPP multi-link. Some of the miscellaneous types of items you can configure for multi-link have load threshold, being able to determine when an additional link is going to be brought up, and also have the minimum links option, being able to specify if I had, say, 3 or 4 links. If I want to say I want to have a minimum of 2 of those for my connection, you can set a minimum level for the number of links used. Optimized PPP negotiation allows a faster negotiation process by predicting responses. So sending an ACK and then sending additional requests before getting ACK back. Sending out expected reply and request packets. Interface commands, PPP LCP predictive and PPP IPCP predictive. So the peer neighbor route. When dealing with PPP and having the negotiation back and forth, part of the negotiation process learning about the other endpoint, having information pass through. So with the peer neighbor route, by default adding a /32 route, the host route for that remote endpoint. Now in most scenarios you have a connection that is a PPP connection, and you have your network mask /24/28/31, whatever it happens to be. In this case, with a peer neighbor route, because you're learning a /32 for that remote endpoint, then it doesn't matter if that device is actually on a completely different subnet. So you could still have reachability because that /32 is learned in the negotiation and then installed in the local routing table as a connected route. So being able to have situations, you may have something like IP unnumbered, but still able to connect to that other side and still have those routes for that remote endpoint. PPP over frame relay, allowing you to take and establish a PPP connection over top of a frame relay DLC. So in this case, having a separate logical layer being added in. So in this case, we have a logical interface using a virtual template. Parameters applied to that logical interface. So IP address, authentication parameters, multi-link options configured on that virtual template rather than the physical, because the physical in this case is now the frame DLC. And then we have the frame relay interface DLC command binding the specific DLC to the specific virtual template. Now in doing so, we have a virtual template created, applied to the frame DLC. A virtual access interface is cloned from that template and is the actual interface you will see in the output of your show commands and your routing tables. The virtual access itself not directly configured, but inheriting those properties from the virtual template. So some additional items, again, being able to look at other features that PPP offers, being able to add in additional items like authentication. So different possibilities you can get into there, but again, just a separate logical overlay of a PPP framing over that frame relay DLC. PPP over Ethernet, or PPPoE. So similar to the PPP over frame type of connection, taking a PPP connection, establishing it over the top of another type of connection. So in this case, over the top of the layer 2 Ethernet connection. Again, similar to the frame, PPP over frame, having that as a separate logical sublayer, address information, authentication information, items being configured on the virtual interfaces. Now, can be dialer interface or can be virtual template depending on which side you're looking at. Some of the earlier examples and the earlier iOS configuration used VPDN groups. However, the newer versions use a BBA broadband access group. So having the logical interface, having the information able to, again, bring in some of the other features and functionalities of PPP. So for example, in the service provider environment, able to have a bridged Ethernet connection handed off, but still able to do authentication of the end client and getting the other features of PPP.